why are we putting organic material that contains carbon into landfills? And this includes like sewage sludge that leaks out and contaminates our water. Why not transform sewage sludge into biocrude oil that can be used for either carbon removal or potentially upgraded into low carbon fuels, which we all need?
Welcome to Sustainability Leaders. I'm Michael Torrance, Chief Sustainability Officer at BMO. On this show, we will talk with leading sustainability practitioners from the corporate, investor, academic, and NGO communities to explore how this rapidly evolving field of sustainability is impacting global investment, business practices, and our world.
The views expressed here are those of the participants and not those of Bank of Montreal, its affiliates, or subsidiaries.
Welcome back to another episode. I am Alma Cortés Selva, Senior Advisor at the BMO Climate Institute. Today, we're talking about how a new technology can turn everyday organic waste, like waste from food manufacturers, farm byproducts, and even sewage matter, from water treatment plants into something that helps fight climate change. Joining me today is Jerry Kristian, co-founder of NuLife GreenTech, a Canadian company that uses a special system to turn bio-waste into carbon-rich material that can be safely stored deep underground for a very long time. Welcome to the show, Jerry.
Thank you very much, Alma. It's my pleasure.
Can we start by what inspired you to co-found NuLife and how you became interested in transforming bio-waste into a climate bio-solution?
That's a great question. It is not a direct path. It was not a university research project. My wife and I, we owned restaurants, and we did everything we could to minimize the amount of waste created, but I still saw material getting thrown out. And I used to think there's got to be value there. Anyway, years go by. I meet my business partner through an entrepreneur owners group, and you get to know people that way, through their highs and their lows. And he and I had decided we would like to maybe do something together, start a business. At the time, his daughter is 6 months younger than my youngest son. And these two kids, or blobs, are in daycare together. They're in diapers, and we're looking at them and we're going, okay, these guys didn't do anything to make this place dirty or mess it up. What can we do to help fix this problem? And because we both come from business, we thought if we can solve a real problem for industry while cleaning up waste and save industry money while we have a profitable business model, then we can leverage the profit motive to maximize our impact.
That's very inspiring. Now, turning many farms and factories deal with waste. It's smelly, it's expensive to get rid of, it's messy. We're talking about canola, processing leftovers, wastewater matter. What do you think is the biggest problem with how this waste is usually managed? And then why does it matter for communities or for the environment?
First, there is actually so much material produced that the general public does not even know about. And it's normally not called waste. It's considered, bioprocessing residues or underutilized material. And a lot of it is not handled in environmentally positive ways that you would hope for. For instance, why are we putting organic material that contains carbon into landfills? And this includes like sewage sludge that leaks out and contaminates our water. Why not transform waste like sewage sludge into biocrude oil that can be used for either carbon removal or potentially upgraded into low carbon fuels, which we all need?
The process that NuLife uses, it's called hydrothermal liquefaction, or HDL. How do you explain it in simple terms? And why is it a good fit to deal with waste?
You know what? That is a fabulous question. And it's one that I get to talk about regularly. So we recreate how oil was formed on Earth. If we think back, there was over millions of years, there was organic material, trees, dinosaurs, whatever, and they piled up. And then there was dirt ended up on top of it. And that created pressure and heat from inside the earth. And there was water present. And over millions of years, that transformed, there were reactions, and we got the oil deposits that we know of and that we use today. Well, hydrothermal liquefaction recreates that process. We use heat water, pressure, and residence time to transform the organic materials into biocrude oil. Now, the big difference is instead of millions of years, we put it through our continuous flow equipment and we transform it in less than 5 minutes from organic material into biocrude oil.
How is the process different from other carbon removal technologies out there?
So we designed our system to be feedstock agnostic and process both wet and dry materials. Some people will design equipment for very, very specific use. We did not. We said, no, we want to be able to have greater application. And we know there's challenges with both wet and dry. Now, few other processes can effectively handle wet waste. Some processes, for instance, like pyrolysis or gasification, they have to dry the material first. And that is not energy efficient. One also has to look at the output optionality. This just makes good business sense. You never only want to have one market or one buyer for whatever you're doing. And that goes back again to us being business guys. So hydrothermal liquefaction, or HTL, produces a high quality biocrude that is much better in quality than, say, pyrolysis bio oil. HTL has double the carbon content and much less impurities like oxygen. Now, why that's important is, well, NuLife, we've already demonstrated that we can upgrade our biocrude into low carbon finished fuels like renewable diesel and sustainable aviation fuel. Also, technologies, again, like pyrolysis and gasification, they have to dry the feedstocks first. And this is, again, just to highlight it, that is extremely costly and energy intensive. And it also depends, what are you trying to produce from it?
One aspect that you didn't touch, but we've talked about, is how your system is modular. There are smaller units, they are placed in many different locations, and it's not like one huge central plant like other technologies. What does this many small systems approach means, and then why does it make it easier and faster and more feasible to quickly grow across Canada and across the world?
To me, it's about impact. And we hear about these $500 million or $1 billion projects. They're sexy, but they're also very challenging to get off the ground. And a lot of cities, municipalities, or industry businesses don't create enough material for a mega system or a mega factory. And so we took a different approach. We said, if we can design this system in a modular way, imagine, a cookie cutter where the core technology is the same. So for us, a commercial deployment has to still be large enough to be economical and beneficial. And it also has to produce enough output for uses at the scale required. And what I mean by that is, is there enough biocrude produced so that can be upgraded into low carbon fuels? Again, we've identified many opportunities that generate annual volumes of around 25,000 dry tons or more. That may sound like a lot, but for instance, a feed mill that processes oat hulls, often they generate around 25 to 30,000 dry tons a year of material. One oatmeal facility. So our CapEx also, by making it modular and scalable, our CapEx is a fraction of these large projects. And so it allows us to reduce deployment and project risk. And also, we can deploy in less than a year. And we're doing that right now, this year, 2026.
At some point in our conversation, you mentioned that NuLife turns waste into two products, bio-oil and biochar, and then store them 1,000 meters underground in regulated salt caverns. Why is storing the carbon underground an important part of your model?
So in the fight against climate change, there's really two main ways to do it. They call it offsets, or you can offset your use of fossil crude. For instance, if you have maybe an electric car, and you charge it from a clean electricity grid, you're offsetting using fossil crude. You're leaving it in the ground. Fabulous. The other side to the fight against climate change is also, there's too much carbon already built up in the atmosphere. So how do we remove some of that? That's often done through carbon capture, utilization, and storage. They'll capture the carbon and sequester it underground. Another way that if people have heard of it is direct air capture. Let's suck the carbon out of the air and we'll inject it underground and permanently sequester it. The thing about, we do very similar process to direct air capture, except that we capture the carbon before it's emitted into nature. We intercept the biomass before it decomposes to emit the carbon. So we intercept it, make it something carbon dense, and allows us to do it at a much lower cost of capital and operating cost. So in regards to permanence is a really, really big thing about this. Imagine, you're buying forests or planting trees. Hey, that's great. It removes carbon. But what happens if a forest fire comes through and burns down that forest and releases all that carbon into the atmosphere? So it's not permanent, okay? The earth itself has locked away materials or stored them for millions and millions of years. It goes back to the geology, inside the earth and the different layers and material can it safely store. Well, it just so happens that Saskatchewan and some of the surrounding area, we have the perfect geology actually for permanent sequestration. So imagine like potash. We have a lot of potash that's mined in Saskatchewan. And there's these pockets or caverns where potash was mined out. Now they're empty. They're impermeable. And they actually self-seal if there's ever a crack in them. And so those are actually used for waste material storage. They've been used for decades. And so there's also been research done that shows that when the bio oil is injected into these caverns, 1,000 meters underground or more, it actually solidifies over time so that reducing any chance of it escaping.
Last December, Frontier announced a $44 million multi-year agreement to buy over 122,000 tons of carbon removal from NuLife. Congratulations. That's a big deal. Big companies like Google and H&M are supporting it. What does this deal mean for NuLife? And then how does it help you grow faster or prove that your technology works?
One word, it brings validation. I'd like to just take a quick moment to give a shout out to Frontier and member companies, and as well, it's not part of Frontier, but like Microsoft. They've identified this is important. They want to support leading edge companies. They want to find the most innovative technologies globally that have the most massive impact for scaling and impact. All right. In September of 2024, we were chosen as one of those companies. We were given what's called a pre-purchase agreement. Essentially, they gave us $500,000 US and said, we love the story. Now go build it bigger and show us that you can do it and deliver us CDRs. Well, we worked on that and we did that through to 2025. We worked really hard. There'll be something we may talk about, registries. And so getting certified. It's kind of like ISO certification, but in the carbon removal space. And so 9 months it took us, we got onto the registry. And so yes, as you mentioned, we received this $44 million US offtake. And they purchase all of our output from our current facility and the one that we're building, all from now until the end of 2030. We are in a very, very blessed position right now because we've sold all of our output. Now we can just focus on delivering, building our next facility, scaling the tech, advancing it. Again, talking about, Frontier, they're the market leader. And this validation, what it means to NuLife, well, we see it in the emails and the requests about opportunities and the support that we get. This is allowing us to build a full commercial facility, to scale and validate our business model, our solution, and our massive opportunity. In conjunction, it allows us to demonstrate a path to significant volumes of biocrude for potential upgrading. So, it's not just about delivering 120,000 CDRs. It's a massive stepping stone, and we are so grateful for it. And we plan on leveraging that to even greater things, greater carbon removals, and greater opportunities for impact.
You mentioned the isometric registry, that you guys are running thousands of hours of commercial systems and have derived carbon removal results through the isometric registry. Why is it so important for you guys to do the verification process and have that third-party certification? And what have you learned that you wish other CDRs or yourself knew at the beginning of the process?
That's an excellent question. And I hope, people listening who may be project developers can take something from that. And if it can save them time, wonderful. Again, the registry is key. It's extremely rigorous process. Took us 9 months. And it is required for a large offtake. Like I said, it's like ISO certification. And it brings robust MRV is kind of the term, that monitoring, reporting, verification. Is the data correct? Is it repeatable? Is it accurate? So that robust MRV is very critical to avoid, dubious actions like double counting or unverified claims. We took great records and data tracking. When I look back and I see how vital that was to the verification process. So take excellent data, all of the data. And when you have a hiccup, don't hide it. Keep it in there. And hopefully you can learn from it, but also it'll then help prove when you build out your certification process.
We've been talking more about the business side, carbon removal, permanence, but this has impact on the cities and industries. This is a real enrichment problem that could be solved. How are you working with the municipalities, with industries to deal with organic waste? And then can you just guide us through the process if you're talking with a municipality or a town or an industry? What does the process look like? And then how are you working together?
It's different. Industry is different than working with municipalities. The timeline, the decision making. So our business model is to build, own, and operate. That may change in the future, but first we must deploy our tech in, just that robustness of our model. So one of the key things that I also want to share for any project developer is the customer discovery process. Pick up the phone and talk to people. And what we have learned is that companies, they don't want to spend money on dealing with their waste or their residuals. They want to invest in their own operations and make themselves better, their products, better processes. From that, we've learned, we ask for no investment. What we ask for is a long-term supply agreement. NuLife will build the facility and then we own all the outputs. We only deploy when it is a win-win with the feedstock, waste generator, feedstock supplier. They must see a tangible benefit, like reducing their cost to address their material and simplifying their work. And those are the benefits that we're seeing. Again, companies are less risk adverse than municipalities. We know that they're signing deals with us. Probably my best example with a municipality is sewage sludge. What is happening to it now? Well, we know it's getting land spread. That entails PFAS, forever chemical risk. It gets sent into landfills. There's leaching concerns or organic bans in the landfills. Landfills are filling up. What else? Well, the big driver with them is how big is the problem to them? We see a desire for a solution, but apprehensiveness to act. They're risk averse. Well, that's okay. I guess their problem is not yet big enough for them to act. We're one of the only processes that can effectively process their wet contaminated sewage sludge. And certain areas of the United States are in a real pickle. Between landfill tipping rates are shooting up in price, they're running out of landfill space and land spreading bans. They're in a very challenging position, all while they're trying to manage taxpayer money. No homeowner wants their property taxes to increase because of a biosolids disposal cost increase. We can lock in that tipping cost for quite a number of years. My belief, based on my experience, is that once there is a solution available, demonstrated, adopted, so it allows to not send biosolids to landfills or land spreading it, then regulations will tighten even more, and then there'll be much quicker adoption. But municipalities want to be a follower. The challenge is to find that lead. And usually that lead is through private industry. So that's where we're going. We know that the municipality market will come in due time, but we industry wants to work with us, which is fabulous.
Super interesting. And my last question, you mentioned really quickly low carbon fuels. That could be one of the end products. What role do you see NuLife playing in low carbon fuels, SAF pathways, negative commodities, and or any other parting thoughts? Where do you guys see in the next 5 to 10 years?
This is an area that really excites me because of the opportunity for massive impact, even globally. So long-haul transport and aviation will take a very long time to wean off, liquid fossil fuels. So let's use ultra-low carbon fuels. I'm going to just touch on something called life cycle analysis and carbon intensity. So if we use diesel as an example, fossil diesel has a carbon intensity of approximately positive 92 grams of CO2 per megajoule. All right, we've done the life cycle analysis, and we've done the LCA to include upgrading. So we've taken our process using actual data from our facility. We've processed the out-hull material, the waste material, the ag residue. We've put that through our process. We've made the biocrude oil. Then we took the biocrude oil, we gave it to our upgrading partner. They put it through their process. So remember, diesel carbon intensity of 92. And the lower the carbon intensity, the greater the value, the greater the impact. The life cycle analysis expert who did this report calculated a finished fuel carbon intensity of a renewable diesel for us of minus 14. So negative 14, which means if you use, for instance, in our region, people will grow canola oil and then they'll process it into a renewable diesel. That carries a carbon intensity of approximately positive 30 to 35. We're negative 14, which means you need less of ours to achieve the same amount of impact. Because you use those ultra low carbon fuels, you blend it into the finished fuels to reduce the average carbon intensity of the fuels that the distributors sell. So we look at it two ways. A, economically, it will earn more low carbon fuel standard credits, but also we're taking our waste material that we're generating every single day, recession proof. Everybody still goes to the washroom, and we're turning it into fuels that we need to power the airline, the airplanes that we love to fly on for long haul transport. We even see that, let's go beyond that. Let's go even beyond the 5 to 10 years. When we no longer need liquid fuels, this biocrude can have other uses. It could become high value plastics or other products for items that are used every day in your cell phone to, your electric car. There's one last level of impact that I would like to leave you with. So Frontier estimates that NuLife's opportunity with manure, sewage sludge, and crop residues is almost 500 million tons a year. That would produce 175 billion liters of renewable diesel and SAF per year. Now that is impact.
Extremely impressive number, because right now you guys are just committed for 122,000. That is really impressive. Thank you for breaking down how waste can be transformed into permanent carbon removal. It's inspiring to hear what you and your team are doing. Thanks to all listeners, and see you next time.
Thanks for listening to Sustainability Leaders. This podcast is presented by BMO. You can find our show on Apple Podcasts, Spotify, or your favorite podcast player. Press the follow button if you want to get notified when new episodes are published. We value your input, so please leave a rating, review, and any feedback that you might have, or visit us at bmo.com/sustainability leaders. Our show and resources are produced with support from BMO's marketing team and Puddle Creative. Until next time, thanks for listening, and have a great week.
For BMO disclosures, please visit bmocm.com/podcast/disclaimer.